So fucking derivatives. Um, yeah, so what the derivative does is it tells you, it measures the instantaneous rate of change or the the slope at a particular point on the graph. So we have a graph here for y equals x squared. And if we're looking, for example, at any particular point, I'm going to choose y equals, x equals 0, just to be safe. If we're looking for the instantaneous slope, that's the tangent line, right? The instantaneous rate of change, that's the tangent line. And the only way you can draw a tangent line through y equals 0 is to have a slope of line 0. So the equation for this line is y equals 0. And so the derivative is a separate function that maps out the slopes of all these points for each x value. So I'm going to start just tabulating values over here. So create a table. Where's the fucking table? Interesting. Okay, we'll just write them out for us, and then I'll show you the derivative later. So 0 is our first, that's our x value. This will be all the values for our derivative function. And well, if we have the function y equals 0, that's equivalent to saying y equals 0x plus 0. And we only care about this part, the m, right? We only care about the slope. So our first point will be 0, 0. Now, let's do -1. I'm going to erase stuff. -1, if we draw the tangent line, actually, I'm going to draw it here. If we draw the tangent line for -1, it'll look something, it should look something like that. You can like verify just by looking at it that this is the tangent line. So if it goes from 3, or if it goes from -2, 3 to -1, 1, well, let's just write it in slope-intercept form. So y equals something x minus 1, right? Because that's the y-intercept. And it goes from -1, 1 to 0, -1. So that's a difference of 2 for every one x value, -2 rather. So -2x minus 1. So we now add the point. Again, we're only looking at this m value. -1, -2. Now what's fantastic about y equals x squared is it's symmetric. So for 1, 1, we're actually going to have 1, comma 2, because as you can see, I mean, I'll just show you. This, we add the tangent line here, and bada bing, bada bam. Once you look at that, it's the same. It's just it's symmetrical for that. All right, let's do like one more, after which it will get tedious. So let's take the point -2 now. So actually, -2 is all the way up here. And then we draw the tangent line to this. Should look a little something like, actually, let me zoom out quickly. Yeah, there we go. Draw the tangent line to this. So -2, 4. We draw the tangent line to that. Should look a little something like that, pretty much. It goes down, goes from -2, 4 to 0, to -1, 0. So y equals, well, I'm just going to do the slope at this point just because it's easier. The slope is -4. So we have -2, -4, and we know it's symmetric, so we'll do 2, 4. So we have all these points. Great. And these points, remember, are the x values of the function, of the original function. So this is f of x, right? So these are the x values. And then these, though, are the slopes, the tangent slopes of the f of x value. So we'll call that something else later. But for now, just take my word for it. So if we write out, this is where the table function, very helpful, Desmos. Let's see. Oh, okay. And then everything actually plus button. There we go. Let's make this color. Well, let's change that color actually. Change it to green. So 0, 0, 2, 1, 2, -2, -4. Okay, so I've just taken these values and I put them in this table. So I'm now going to clear the screen. So we are now plotting the points on a new function, and this will be our derivative function. And now let's just try and fit just a normal line through this function and see what we get. And so we can see that the y-intercept is 0, and it has a slope of 2. And indeed, the derivative of y equals x squared is y equals 2x. So let me come over here, x, make the screen, clear all the screen, boom, that's the derivative. So this doesn't line up with the function, as you can see. It's not supposed to line up with the function. What it does is it tells us the slope of the tangent line at any particular point. And I've repeated that a couple times already, but it's important, so I'm going to repeat it again. So at this point here, 1, the slope of the tangent to this is 2, which is the y value of this function. So the y value of the derivative function is the tangent slope of the original function at that x value. I hope that makes sense. That's very important. I don't know. I'll just go over other stuff quickly. There's a couple ways to write the derivative. So you can call it y prime, you can call it dy dx, or you can call it f prime x. You'll see it all the different ways, but it's all that sort of fun stuff. Let's see, other stuff. Yeah, so you can actually, there's a technical definition for derivatives, which is this thing. I don't know how much calc you've done, so I don't know if you've done limits, but let's just assume you have. If not, you don't need to know this. You can just skip this part of the video. You can skip the whole video, actually. I mean, you've already made it this far, but like, no one's forcing you to watch this. All right, anyway, so basically what this is saying is, let's say you have a curve like this and choose 2 points on it. So let's choose 2 points on it. So that's a point. Okay, sure, be in red, why not? And that's a point. And this is, sure, whatever. Okay, so this is point x f of x. and this is point x plus h. So let's just call the distance between them h, and then f of x plus h. All right. So just trust me on those. Like we're just saying all this is doing is saying this is a distance of h. Okay. So if you take the slope here, what you're not going to get the tangent, right? You're going to get an average slope between the two. However, what if we made the distance between them shorter? I can't move this stamp. Okay. What if we? So actually, I should make this like a star, and make this one a heart. So what if we made h smaller? As we make h smaller, so that's the first line, right? Make h smaller, it becomes closer and closer to the tangent. And so that's what the limit is saying. The limit is saying make h as close to 0 as possible. And as you do that, and so all this is doing is, this is our slope formula. This is y2 minus y1 over x2 minus x1. So we know this is the difference in the x values, right? Well, we call the difference in the x values h. So that's where the h comes from. The second y value is f of x plus h, and the first y value is f of x. Now that's a lot of arrows, but I'm basically showing you where it comes from. So this is the definition, the technical definition of a derivative. However, you probably don't really need to know that. Like, it doesn't even come up that much in my class. So the important thing is just to note what a derivative is, which it is a function that tells you the slope, and this is key, only the slope of its original function at that particular x point. The instantaneous slope, the tangent line, the instantaneous rate of change, whatever you want to call it. That's what it tells you. I don't know what else you've done. Like, have you guys done power rule yet? Like, there's a really easy way to take. Actually, hold on. Can I do derivative? dy dx. That works. So, okay, look. Basically, to show you that I'm not just lying to you about this, I'm saying this is the derivative d dx of x squared, of x squared. Let me make this a different color. Purple and green are the same line. They're the same thing. So y equals 2x is the same as the derivative of x squared. And I mean, you can tell this very easily if you've already done the power rule, because y equals x squared, power rule, you take this, you bring it out front, and you subtract that by 1. Honestly, if you want to know about the power rule, I'll just do like another video. But yeah, and then there's like really fun stuff like y equals e to the x. Wait, I'm gonna show you guys this. This is gonna be really cool, guys. Wait till you see this. All right, whatever. We're just fucking around at this point. Okay. Y equals e to the x. Okay. Y equals e to the x. Right, now watch this. I'm gonna come over here and I'm gonna take the derivative of e to the x. Guys, they're the same. That's what makes e so important, is that its derivative is the same as its base function. So at any point, its instantaneous slope is the same as its as the value on the graph. Isn't that crazy, guys? Man, you guys, I can tell right now, you guys are like, whoa, that's crazy. Let's see what else. Honestly, not much, but like, what if I did y equals e to the I pi? Then your minds would really be blown. Where's pi? Oh, there it is. Okay, did not do what I wanted it to do. Sad. Okay. Well, such is life. Yeah, I don't know. What else is going on? So other stuff about derivatives. Um, yeah, then you can do is I didn't say I said chain rule earlier. I did not mean chain rule. I meant power rule. Power rule. There's a fucking you know um I mean chain rule is kind of a little bit annoying, but like mostly fun. Yeah, I don't know. Let's see. Here's a fun XKCD cartoon that is it's the one from today. And I was like, oh, this will be good. So yeah, I should have said for the sake of simplicity more probably. It's important, important aspect. Let's see what else is going on. I mean, I don't know if I'm forgetting anything. It's definitely possible. Hmm. Da, 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 da. Hmm. Do, 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 do. Yeah, I'm just gonna end the video now. It's been a pleasure.